So let's start. Today we will discuss metal detector, Geonics EM61Lite, integrated with drone, usage scenarios, some expectations. We will discuss some expectations, what we can detect, on what depth, and how to plan missions, and how to process the data. Couple of words about our company. Our company called SPH Engineering, Smart Planes and Helicopters. And we started 8 years ago. Our main product is UgCS, Universal Ground Control Software, and many of our customers know us about under the name of our first product, but company name is SPH Engineering. UgCS, it's the name of our oldest product. We have different product lines. Mentioned UgCS, drone show software, Mapper, UgCS Industrial Solutions, Atlas. It is our latest product to process data using artificial intelligence, command and control systems. And today we will discuss new sensor in our industrial solutions. What is industrial solutions in our terms? It is complex sensor integrated with a drone. Currently, we support ground penetrating radars, echo sounders, metal detectors, magnetometers, metal detectors, and we integrated few custom sensors for our customers, like a sound velocity profiler and gamma radiation sensor. All integration is based on the single and unified software and hardware stack. It is a universal ground control software and onboard computer called UgCS SkyHub. And of course, set of equipment includes drone. Usually it is DJI heavy lift drone like M600 Pro or similar drone based on Pixhawk Autopilot. Let's return to metal detector. What is included to the system? First, of course, it is Geonics EM61Lite time domain metal detector. It consists of 3 main pieces. Bottom sensor coil here, compensation coil to suppress the noise from the drone, and electronics block mounted under the hull of the drone. Second important component of the system is SkyHub onboard computer. It is a small black box hidden here. Its main function is to run software, onboard software, to record the data from metal detector, and to control flight in terrain following mode using altimeter, usually fixed on the arm of drone. Of course, we use appropriate drone. Here on photo is DJI M600, but you can use similar drones, similar in terms of payload capabilities. Weight of the system, weight of payload is approximately 5.5 kilograms. So you cannot use small drones or even medium drones like DJI M210 or a new one, DJI M300 with such big payload. Optional component is RTK or PPK GNSS receiver. It can be installed as additional equipment on the drone to log precise coordinates, or if your drone is already equipped by RTK receiver or RTK receiver, SkyHub will log the data together with centimeter level precision coordinates. And last piece of hardware, last but quite important, is power converter to feed the power to metal detector and remotely controlled relay. Why relay is important? Electromagnetic impulses generated by metal detector is so strong that you cannot activate metal detector on the ground together with drone, or you will get compass error during the drone initialization. So a recommended sequence is to power drone first, wait until initialization, and next activate metal detector. Most convenient way if you have possibility to do that from ground station. And of course, system includes a lot of software. It is onboard software for UgCS SkyHub computer to log the data and to manage flight in terrain following mode. UgCS ground control software to plan and execute mission. Additional piece of software called UgCS custom payload monitor. I will demonstrate it later. That software will allow to set parameters of terrain following mode and also to receive online data from sensor. And last but also very important, processing software. Application scenarios. As funny metal detector, you can use the system to detect any metal objects, magnetic and non-magnetic. When you can prefer to use metal detector mounted on the drone. First case, when you cannot use ground metal detectors, handheld or mounted on the cart, like on photo here. For example, area for survey can be dangerous, or it can be not comfortable to walk or to push the cart with mounted metal detector. Or in some cases, drone plus metal detector will provide better productivity. And sectors or application scenarios are pretty standard. Most popular are three. It is unexploded ordnance detection, locating underground infrastructure, and archaeology. But in general, any task when you need to detect metallic objects. One comment about photo. Here you can see standard EM61MK2 metal detector in standard configuration on card. It is father of our metal detector. EM61Lite, from technical point of view, is absolutely the same as a standard version, but modified and lightened to use it with drone. Everything, it is message for existing customers or users standard version of metal detector. From drone, you can get the same results as from standard version. Most tricky part of webinar is the capabilities of the system. Why tricky? Because if you will ask similar question about any geophysical sensor, can I detect something on the ground, on the depth X? Answer will, it depends. So detection capability of metal detector also depends on a lot of factors. Main and obvious factor is, of course, distance between object and sensor coil. But also a very important characteristics of the target. It's a size, shape, target orientation on the ground, material composition, thickness, integrity, many factors. Very interesting that weight of the target is not in the list. Usually, potential customers asked us about probability to detect piece of metal, for example, 200 grams. But weight is not important factor. Also interesting that system can be operated over salt water, so you can use the system to find metallic objects on the bottom or under the bottom of fresh water and in salt water. And capabilities of the system will be more or less the same. So there's a lot of considerations, but they will not give you precise answers what you can detect. And as with any geophysical sensors or as with any complex sensors, it's better to operate by test data from surveys over known targets. So I will demonstrate you a couple of samples. First sample is for scenario of detecting underground anomalies and steel barrels. It is our own data from our test range near our office. And when I will show you how to process the data, I will use data related to that sample. Interesting. What is interesting here? That data from metal detector usually is very clear and don't require additional processing to remove noises, to do some complex data transformation, as with many other geophysical sensors. And you can see that even quite small pipes in diameter of 5 centimeters, it is target number 8 here, produces very visible anomaly. Very visible, I mean in processed data. How to use demonstrated data? You can see here distance from between coil and detected target. So in most cases, it doesn't matter. I'm sorry. So it is distance, it is not depth, it is flight altitude plus depth. For example, 1.5 meters here can be 1 meter deep and half of meter altitude of coil, of sensor coil over ground. But it can be also half of meter deep and 1 meter altitude. So main factor is not depth, not altitude, but distance between object and sensor coil together. You can see here 2 numbers because pipes here placed on the ground in diagonal orientation. It is to test response from the target from different depth. And very important that according to gathered data, most of targets here can be detected from much bigger distance comparing with our test data. For example, reinforced concrete pipe here, target number 7, produced so huge anomaly from the distance 2.1 and 3.1 meters at the deep end of pipe that I am pretty sure that it will be detected from at least 5 meters. And the same related to all targets. So it is not maximum detection capability for test targets. It's just results of particular test. Second standard scenario, it is unexploded ordnance detection. Maybe it is one of main applications of metal detectors. And what is very interesting here, it is difference of detection range depending on target orientation. Most extreme sample is 20 millimeters projectile. It is a photo of projectile is here, almost in real size. And if projectile is in vertical orientation, it can be detected on the distance 58 plus 40 centimeters, almost 1 meter from sensor. But if projectile will be in horizontal orientation, detection range is reduced to approximately half of meter, almost twice. It is fact what we have to consider when we are planning our surveys. And you can see that for targets which have not so narrow shape, difference between difference in detection range for depending on orientation is not so big. It is also very important when you plan your surveys. Next part of discussion is a difference between sensors. Currently, we provide 3 types of sensors which can detect something on the ground. It is new sensor, metal detector, magnetometer, and ground penetrating radar. All sensors have own capabilities, own benefits, and drawbacks. Here is short discussion. Metal detector, main benefit comparing to the magnetometer, that it can detect both ferrous and non-ferrous metallic items, magnetic and non-magnetic metals. For magnetometer, to detect non-magnetic metals like aluminum, it should be huge amount of non-magnetic metal to detect some magnetic anomaly. If you need to detect something made from aluminum, bronze, silver, gold, you need to use electromagnetic impulse metal detector. Comparing to the magnetometer, metal detector usually can detect smaller items. But I should say, because we received already many requests about capability to detect small coins, for example. If you want to detect such small items, our system most probably is not for your scenario. You will have to use handheld metal detectors. Also, metal detector is less suspicious to noise from magnetic soils like iron ore, and from noises from different metallic trash on the ground, from different cultural noises. Comparing to the magnetometer, metal detector has much better target localization and resolution, because you will, as coordinates of the target, you will have quite small area inside of sensor coil. Usually, detected anomaly from magnetometer will have 2 parts, positive and negative part of anomaly, and it will be bigger. So if you use magnetometer to detect relatively small metallic objects, before excavation, it will be better to use handheld metal detector to localize target. In case of airborne metal detector, you can rely on gathered data from the drone. And for metal detector, process and workflow of data processing interpretation is pretty simple. Benefits of magnetometers. Standard weight of magnetometer of airborne magnetometer for drone is around 1 kilogram. That means that most magnetometers can be used with medium drones, and some magnetometers can be mounted on the legs of drone. That means that you can use the system in windy weather. And if you want to detect big anomalies, big metallic items on the big depth, magnetometer will work for you better. Maximum detection range, I mean distance between sensor coil and detectable item for EM61Lite Metal detector is around 5 meters. If you need to detect, say, couple of hundreds of kilogram target at the depth 10 meters, magnetometer will work. Metal detector will not work. Next sensor capable to detect underground anomalies is ground penetrating radar. Main benefit of GPR is possibility to estimate depth. Metal detector and magnetometer in general will not allow you to measure or estimate with more or less high precision depth of detected target. There is a standard joke related to magnetometer. Bullet or small metallic item on the distance 20 centimeters from magnetometer will produce the same magnetic anomaly as a nuclear submarine on the depth 200 meters. Based on magnetometer data or based on metal detector data, if you don't know estimated depth or estimated characteristics of the target, you cannot predict depth. Using GPR, you can measure or estimate depth of target with quite high precision. It is reason why we recommended to use ground penetrating radars as a secondary sensor. If you detect something by metal detector or by magnetometer, you can use ground penetrating radar to measure depth of target before excavation, because it is very big difference. Something on the depth of a couple of dozens of centimeters or big target at the depth 10 meters, very big difference. And also obvious benefit of ground penetrating radars if you need to detect non-metallic anomalies. For example, for scenario of underground anomalies, underground utilities detection, you will have to use a combination of the sensors. Metal detector will give you best possible results for metallic utilities. Ground penetrating radars will allow you to detect, for example, plastic pipes. And of course, drawbacks of the sensors. Metal detector, quite bulky and quite heavy. Weight of payload is around 5.5 kilograms. And as you saw on the photo on first slide of presentation, it should be fixed on ropes under the drone. So you cannot operate that system in windy weather, and you have to use quite big drones. Drawback of magnetometer: data processing can be tricky in some situations, and in many situations, to get clean data, you will have to use a magnetic base station, additional piece of equipment. It is especially important to use magnetic base station if you are working in areas like Greenland, north of Alaska, when there are big variations of natural magnetic field during the survey time, or if you want to align magnetic data gathered at different time. And magnetometers, as I already said, cannot detect, usually cannot detect non-magnetic metallic items. Drawbacks of ground penetrating radar: it's the most complex data processing and interpretation. You will see something, and most probably to work with ground penetrating radar, you will need to hire experienced geophysicists with experience with GPR data to help you to process and important to interpret the data. In case of artificial targets like underground utilities, in most cases, you will see clear hyperbolas in ground penetrating radar, but sometimes data processing can be tricky. Also, ground penetrating radars are most sensitive sensor to soil and environmental conditions. For example, if you will try to use ground penetrating radar right after strong rain, most probably it will not work. You will need to wait until the soil will be dried. But metal detector and magnetometers will work. And also, most GPR systems are bulky and quite heavy, and also will require big drones. I hope that in few weeks, maybe in January or February, we will prepare data for a new webinar about different sensors based on the real data from our test ranges, and we will discuss benefits, drawbacks, issues of different sensors, having real data from known test targets. Next, I will demonstrate mission planning for a metal detector and mission execution. What we should take in opinion when we plan metal detection missions. First, if you want to detect some small targets, not targets like pipes, we should use quite short distance between survey lines to not miss our small targets between survey lines. Sensor coil width is around, not around, exactly 1 meter. To detect targets with high probability, we need to pass the sensor over target. Target should be inside of sensor coil. So we recommend 70 centimeters to have some overlapping between our lanes to not miss targets if drone will not follow survey lines with very high precision. Recommended altitude as low as possible. You saw data about detection of our test targets or unexploded ordnance with given distance between sensor and target. So higher altitude in any case will mean less probability to detect deeper targets. So depending on your conditions, I mean vegetation, of course, you should select lowest safe altitude. Very important that if you're flying in areas like desert or filled with grass, you can select very low altitude, because even if you will touch the ground by lower coil of sensor, most probably drone will continue to fly. The only risky situation if sensor coil will be catched by something on the ground, and for that your drone operator should have a remote controller of your drone in hands to interrupt and automatic mission execution if bottom coil will be catched by something. But general recommendation is to fly as slowly as possible, and remember that you can, in most cases, you can touch the ground by lower coil of sensor. And recommended speed for survey is between 1 and 2 meters per second. It is not only because of very low recommended fly altitude, but also because of heavy weight of sensor coil on the ropes. If you will fly with bigger speed, drone will not be very stable in the air, especially in turn points. So maximum flight recommended flight altitude is around 2 meters. And short demo how to plan the mission. I will demonstrate two kinds of missions. First mission will be to detect underground utilities like pipes. We have to use our universal ground control software to plan the missions because all other components of integrated system rely on UgCS as a background of integrated system. First step, it is our test range and our office here with known test targets. And first step is to draw our survey area. Next, we need to set flight direction. In general, to minimize flight time, flight direction should be parallel to the longest side of our survey area. In most cases, with that direction, we will have minimal flight time. But if we are going to detect some linear object like pipe, best if we will pass linear object in course close to perpendicular. It is better variant to detect linear object. If you don't know direction of linear objects, you can use direction of survey lines to minimize flight time. Second, we have to set distance between survey lines. Recommended distance 70 centimeters we can ignore here because we want to detect pipes which are quite long targets, and to trace pipes in most cases we will need to detect it with some step of maybe 2, maybe 5, maybe even 10 meters between points of detections. So here we can use, for example, 4 2 meters. And also standard metallic pipe, metallic barrels here are also pretty big targets, and they will be detected even if distance between survey lines is around 2 meters. Also, we may want to add takeoff position for our drone, waypoint near takeoff position for our survey, and mission is ready. We can fly. Second road is to detect unexploded ordnance. Here we have two areas with different soils to detect, to test detection of small items. And I will create new road here. In general, the steps are absolutely the same, but here we will have to use short distance between survey lines. What is interesting here? When we have our routes created, we can estimate flight time required to cover our survey area using standard drones. If we will use flight speed around 1 meter per second, we can check required flight time, 7 minutes. For that area, approximately 9 per 34 meters in size. Quite small area, but it will be covered by approximately in 7 minutes. For DJI M600 with metal detector, it will be approximately half of available flight time. I mean, available flight time for single set of batteries. For that bigger area, if we will use the same speed, 1 meter per second, area size is almost 70 per 45 meters. Oh, it's something wrong. With first waypoint. Okay. Total flight time will be almost 30 minutes. So to cover that area, you will need 2 sets of batteries. And flight sequence. When we have our equipment ready in the field, we will need, as usual, upload route to the drone. And next step, we will need to set parameters for terrain following, because for missions with metal detector, we have to use true terrain following feature of integrated system to keep the sensor on very low fixed altitude over ground. Here we can set, for example, 2 meters altitude. Why 2 meters? Because sensor is fixed on ropes under the drone, and length of rope between drone and lower sensor coil is approximately 1.4 meters. So if we will want to fly with distance, for example, 40 centimeters between ground and sensor coil, we will need to set 1.8 meters altitude. And here we will set flight speed. We will need to write terrain following parameters to the drone. In case of real equipment, activate button will be enabled, and we will need to start our mission. And next, with real equipment, click activate button. And drone will follow route using data from radar altimeter. During the flight, operator can see real-time data from metal detector. Currently, it is of course some simulated random data. Based on our experience, operator will see when drone will fly over targets like pipes or barrels or something quite visible. But it is only subset of the data. Metal detector EM61Lite has 4 channels. Each channel corresponds to different time windows when sensor collects the data after emitted electromagnetic impulse. Having 4 channels, we can classify data because usually bigger targets will be more visible in 3rd or 4th channels of metal detector, but smaller targets usually will be more visible in 1st channels. Here, during the flight, operator will see unlight data only from 1st channel of metal detector, but full data together with coordinates will be logged on board of the drone, and after the flight, you will need to download data to your laptop for processing. I will interrupt the flight. Boom. To download data, you will need to connect from your laptop to SkyHub computer using Wi-Fi network and use custom payload monitor to download data and system logs. What you will have after flight? You will have comma-separated values file. With logged drone coordinates, some data about drone orientation in the air, GPS time, and measured altitude. Altitude measured using barometric altimeter and from radar altimeter connected to the SkyHub computer, and of course data from all 4 channels of metal detector. So for your flights, you will get more or less the same data. If your drone will be equipped by RTK receiver, here in the data you will have additional columns with RTK with precise RTK coordinates. Also, if you use drones like DJI M600 Pro and additional PPK or RTK receiver, you can like Emily Rich, you can connect it also to SkyHub, and SkyHub will log coordinates from external receiver. It will allow you on the next step use precise coordinates without additional post-processing of coordinates. If you will use additional external RTK or PPK receiver, you can refine coordinates in post-processing using GPS time recorded here for each measurement of sensor. Next, what I want to demonstrate is data processing. We recommend to use Sequent Oasis Montage or Golden Software Surfer, but in general, you can use any software capable of processing XYZ data. XY coordinates and Z are data from metal detector. There are a lot of software on the market which will allow you to process magnetic data. It is not mandatory to have some filtering or noise cleaning or some complex data processing function in software, because usually in most cases data from metal detector will be very clear and will not require additional data cleaning. But I will demonstrate data processing in Sequent Oasis Montage because of simple reason. I personally use Oasis Montage to process data from different sensors. Okay, first step is new project creation. And we need to create database to import data from CSV files. Next step is import. I will select all 3 files with test data. And I already have pre-created template for import. Template is textual file with mapping between CSV file and Geosoft Oasis Montage database. Now data is imported. We can check names of our files here. And next standard step is coordinate system conversion. Our SkyHub computer will log the data in UgCS 84 using latitude and longitude coordinates. But in most cases, you and your customer will prefer to use some local coordinate system. I will use UTM zone 35N. It is UTM zone for Riga. or at least for our test range. I have to specify current coordinate system. And specify where we will store new coordinates and new coordinate system. UTM-35N. Okay, we have UTM coordinates. Next step is generating grids from our data. I will use minimum curvature algorithm, and I will do that 4 times because we have 4 channels from metal detector, and usually you will compare visually grids generated from 4 channels and select one grid where your anomalies, your targets are more visible. Select first channel and grid for channel 1. Second. One more. And last one. Now we can compare what we have. All 4 channels. Better resolution we see for last channel, but it seems that here we almost lost 2 pipes here. It seems that better is use second channel. All targets are clearly visible, and we have all targets visible here. We already asked about our test data, why we have noise here. Here, in first channel, it is noise is more visible. It is because of pipe road here and under asphalt. There are tiles made from reinforced concrete. Noise in first lines of our survey is from road. Next step is to generate map. we need to select a database with data, we need to specify map name, and because map is kind of a report, we can select size of our map and corresponding map scale. And drag and drop our grid on the map. What we can do more? First, we can import or we download from internet background map. And new feature of latest version of Oasis Montage is capability to import KML files. It can be very important if you have some information, maybe preliminary information about underground utilities. For our test range, I have a KML file with coordinates of our test targets. And we can compare here how accurate data we have. So we can see that all metallic targets are detected. Non-detected targets are made from different kinds of plastic. We can check it here. So first target here is stainless steel pipe, that one. Next is half of meter in diameter steel pipe also. Plastic, next again steel pipe, plastic, steel, plastic, steel, plastic, steel, and the same with barrels. Plastic, 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 steel, plastic, steel. Oh, sorry, I'm wrong. Plastic, plastic, steel, plastic, steel, plastic. So steel targets are detected. Why we have 4 barrels here, 4 steel barrels here? As you saw, detection range and or probability to detect target on certain depth depends not only on size of target, but also on target orientation and its state. So here we have 4 steel barrels in different orientation. That barrel is vertical, horizontal, diagonal, and last one is crushed. It is almost flat. But we can see that all 4 barrels are detected. And what we also can do with map. Standard question is how to deliver results to the customer. First, we can export data as PDF. And of course, we can add here different annotations, grid, stamp, anything what you need to prepare official report. But simple way, we can export KMZ file. I will hide background map first. And we'll export KMZ file. And now you can send that KMZ file to the customer, and customer can use standard free software Google Earth Pro to check what you detected. It is free software and you can download it from Google site. And if you need, you also can generate 3D model of your data. In many cases, in 3D, you can see by your eyes small anomalies. So 3D can be very useful not only to provide beautiful results to your customer, for your customers, but also to find small anomalies. I will reduce scale, and now we have 3D. Oh. Maybe 0.55 will be better. Yes. So huge anomaly is from big pipe made from reinforced concrete, different metallic pipes, 4 barrels, and thin metallic pipes. That one is diameter of that pipe is 5 or 6 centimeters. I don't remember. That pipe is around is 11 centimeters. All targets are pretty visible and detected. If you are interested, flight altitude for that survey was 2.5 meters above ground level, and distance between sensor coil and ground was 1 meter 10 centimeters. Very high altitude for metal detector missions. That's all, and we can proceed to questions and answers session.
Yes, we have some questions, so will you read them out and answer directly?
Yes, why not?
Thanks.
Question is how you do the correction of the depth of detected metal or utilities. I already explained that using metal detector, you cannot, in general, you cannot measure the depth. To measure the depth, you will have to use second sensor, ground penetrating radar, or make excavations and measure depth, and having measured depth till, for example, pipe in some places, and having magnetic data, you after that you can make some estimations of the depth between your between points with known depth using amplitude of values in data from metal detector. But in general, if you don't have additional information, you cannot measure the depth using metal detector only. The same related to magnetometer. What is the greatest distance between coil and target to continue to get results? Answer is it depends. So you saw in samples that some kind of bomb, 500-pound bomb, can be detected till on the distance 5 meters. And it is close to the maximum detection range for metal detector for any targets. If your targets are deeper, you will have to use magnetometers. Or second option, Geonics manufactures EM61 high power metal detector with extended range, but it is heavy and cannot be used from the drone. But it is option for terrestrial surveys from the ground. Can your sensor detect improvised explosive devices and landmines in the ground, and what will be the sweeping width and speed and be if used on roads? If improvised explosive devices and landmines are made from metal of any kind, they can be detected by metal detector. But usually such devices and modern landmines are made from plastic or have something like plastic bottle from Coca-Cola instead of casing. In general, it is not recommended to use only a metal detector to detect such targets. So you will have to use combination of different sensors, but we don't position to metal detector on the drone to detect improvised explosive devices and landmines. We prefer to work in areas when probability to detect targets is high, and risk of because of not detection of targets is more or less low. So I don't want to comment more that scenario. How would you mark the detected targets for combat engineers to remove or neutralize the traits? You can mark targets in processing software and provide coordinates of detected targets. So in the field, it will be a second step of work to mark detected targets using coordinates with help of GPS receiver, for example. At what point do you know the EM61Lite? Do you mean null to reset metal detector? We didn't implement that function because in reality it is for operator comfort only, and we need to test how it will work when device is fixed on under the drone. But in general, it will not reduce probability or capability of the system to detect something, because if we will not null the sensor, we will just have a different average level of readings. As you saw in our data, For channels, we have some average value, which is far from zero, but it doesn't have any side effects for detection capabilities. But we are discussing, we started to discuss necessity of that function with Geonics. Maybe we will implement it. Can the system detect metal coins? In general, no. Coins are quite small. As reference, you can use data for unexploded ordnance. 20 millimeters projectile, quite big target comparing with coin, can be detected, but if it is close to the surface, most probably coins will not be detected. If the EM61 will use the same power source, in recommended configuration, yes. EM61Lite consumes, as I remember, around 20 watts, and it is almost nothing comparing to the power consumption of drone itself. Flight time for DJI M600 Pro will be around 15 minutes. Does second coil, next question. Does second coil works like standard EM61 focusing coil, or it's only for suppress noise? Main purpose is to suppress noise. For me, it is something new that standard in standard configuration upper coil is used for focusing. For us, it is compensation coil. It's noise removal coil. If you are using the radar sensor to maintain the altitude, why isn't the alt measurement more consistent? I don't understand the question. Here is readings from radar altimeter, and here is altitude from barometric altimeter. Filtered altitude is the same because we didn't use low pass filter for altitude measurements here. So I'm sorry, but I don't understand the question. Normally, next question or comment, normally EM61 records, both for coils, respond separately. For light modification, we in output data from sensor, we have 4 channels, and how data is joined or fused inside of metal detector, I don't know. If it's interesting, we can ask Geonics.
So yes, and one more question, maybe it is already answered in written, but does your system include the data logging of the data? Is the data transmitted back to the base in real time, or logged on the UAV?
Answer is we have onboard data logger, SkyHub onboard computer. file with data, what you see on screen now, is downloaded from SkyHub after the flight. During the flight, you will see data from one channel of metal detector only, and data is not recorded on the ground during the flight. Data is recorded on board of the drone.
Okay, thank you.
Next question, it will be great in order to understand producer data and compare it with standard EM61 data. Yes, you can go to our storage, public storage of data samples. We have a lot of demo data sets for different sensors. For metal detector data, demonstrated sample is here. And you can download data and compare, and it will be interesting to get some feedback from you.
Yes, the link to data samples is also on our industrial.ugcs.com site, so please visit to have the link to the data sets.
And question about data of standard EM61 and UAV-based EM61Lite. For the same area, answer is no. It's a good question. We didn't have a chance to test standard EM61, but we can ask Geonics to do such test when they will produce next airborne EM61Lite and compare the data. It's a good question, but current answer is no.